So let me do a show of hands to start with. Paul did one before, but okay, sorry. So who is involved with drones? Let's do that one again. Drones, okay, so we have very few. Okay, software, PHP development, GIS systems, image analytics. Okay, that's interesting, right. Yeah, just to give me a sense of the audience here. So we are a drone company, kind of. Okay, I'm going to follow my cues here. You can see the subtitle here is it's the conversion of drone data into powerful asset management information in the cloud. That's what we do, okay? So the drone, as Paul mentioned, it's a sensor. Yeah, that's why it fits into the whole IOT concept. So that's great, but a drone gets you a book of photographs, and clients don't buy books of photographs, they buy analyzed information. Okay, so let's, well, don't do that thing. See if we can get this to work. So, now, Paul did a bit of a sales pitch. I'm going to do a lot of a sales pitch because it explains the journey. So we are the world leaders in this technology. That's not my chat, it's from Shell, BP, ConocoPhillips, ExxonMobil, the big oil and gas companies. Our segments are not manufacturing HDMI cables. Let's try that again. Our segments are utilities, renewables, oil and gas, and rail. And we're international. We have offices in Europe, Asia, and the Middle East. Now, safe and proven, we say. We haven't actually had any major incidents, which is great. We've been going since 2008, 10,000 flights so far. That's, depending on who you believe, 5 or 10 times more than the competition. 2,000 plus structural inspections, and 200 live flare inspections, actually more than. So a flare stack is the tall thing you have in offshore oil and gas platforms or onshore refineries with the flames coming out of it. So we can inspect those assets with the flame actually still there, with the production live. So for the client, there's a huge saving. One is health and safety, reduction or elimination of working at height, which is the #1 killer in terms of UK industrial accidents. And the second thing is the client saves a fortune. Recent inspection in Nigeria, there were 4 days of inspection, and had they actually stopped production for those 4 days and done it traditionally by climbing that with rope access guys, they would have actually lost 11 million bucks. So we saved them 11 million pounds from 4 days of inspection. So drones are changing the game in terms of the industrial landscape. Excuse me. Yeah, overused word, we're innovative. Now I'm going to back that up because I can't just say that in a vacuous way. So we have 25 world firsts, world's first offshore wind turbine inspection, world first offshore underdeck inspection on an oil platform, first offshore flare inspection. I could go on, they're on the website. We're also the first guys to develop the IHawk solution. Now, IHawk for us is a cloud-based asset management solution that converts the data into information. And we also have the most highly trained pilots in the industry as well. Now, I will touch on the topic, Simon, honestly. We'll get to autonomy in a second. Now, this is our reaction to the current state of the art, the actual state of the art. Now, we'll talk about agriculture and mapping. That's a very different thing to what we do. And so, in terms of Cyberhawk, our pilot training is 4 levels above the CAA level. So, to get a CAA qualification to fly, you're down here. To get to offshore oil and gas, we've got no fewer than 4 levels of internal training and certification to get to that point. And that's because of the current state of the technology. You cannot safely fly autonomously in an offshore oil and gas situation, or an onshore oil and gas situation, or utilities, or a wind turbine inspection. It's not currently safe. So hence the intensive training we have within Cyberhawk. And yeah, this is a bit salesy. So we have time-served land surveyors and inspection engineers. And for those of you who follow your utility markets, we have Ian Marchant, former chief exec of SSE, on the board as well. Okay, quick flash of example clients. We work for all tier 1 players, yeah? People get very excited by the technology, and you can see by the client list they can come back and buy more of the solutions. And the other thing to mention here is what we actually offer as a service. So there are 2 categories here. One is inspection and one is aerial land survey. In inspection, we have the majority of our business in the first 2 columns, so that's utilities and oil and gas. We also have a growing business in renewables inspection, particularly wind turbines, and you can see some other assets we inspect as well. Also, we have thermal inspection, and there was a question about gas sensing. So we do have a gas sensor which we developed for oil and gas use, and it's essentially a hydrocarbon alarm. So it's sampling the gases for hydrocarbons to make sure it doesn't go above the lower explosive limit. So that is a key use of the technology, and this is because for those of you who are in the oil and gas world. I don't think anybody here, but it's because the drones are not ATEX related. They're a spark risk, which means we have to be able to detect the gas and make sure there's no spark risk in the atmosphere. This is land survey, so this is what you saw from Paul before. So a big chunk of our business is this as well. And you see a number of columns here. DEMs, anybody? Okay, obviously Paul and Crispin, yeah, no problem there. Orthophoto, do these mean anything to you guys? Not so much. Okay, just very briefly. So in terms of what we do, Paul mentioned stereo photogrammetry. So that's what we use. We take a series of overlapping photographs of an asset. We use some software to turn those photographs into a three-dimensional model, a point cloud of the asset in question. And you saw some very great point clouds of Edinburgh before. And that is essentially what we're doing with the software. The orthophoto is taking those overlapping photographs and essentially making them a perfect top-down map. Okay, so one pixel might be 2 or 3 centimeters in real life. So these are the techniques we can use, and this is where you find a degree of autonomy in the drone world. Yeah, but in the previous slide in inspection, you don't, at least not safely. Sphericals and obliques we'll leave for another time. Right, so I'm going to play a quick video here, I hope. That's my intention. So this is an example of our solutions combined in utilities. I'm going to step out the way here. Okay, so we'll stop it there. This is a maintenance solution we've got as well. So what you saw there was a few concepts which are key to Cyberhawk. You had a definition of the client's expectations, you had a definition of a flight plan, you had capture of the data in the field, conversion of that data into management information, and then pushing that data into a cloud-based GIS Lite, we call it, system, which we call IHawk. So a lot going on there. We've done the same thing in a number of other industries. So this is what you saw. Actually, let's do a bit of a test here. This is a utilities example. So the test here, it's a spot difference, yeah? So you see on the right-hand side, you have things which are called insulator strings. And the problem with this is that red 4 there, that's the defect. Okay, so the clue I'll give you is the back one is perfect, and the one in the foreground is a catastrophic defect. So can anybody see the difference between the one in the background and the one in the foreground? Okay, well, I mean, inspection guys sometimes don't get this. Let me just jump across here. So the defect here is for something called an arcing horn. The arcing horn is this thing you see here, yeah? And here it's completely absent, yeah? So that's why it's a catastrophic defect, it's just not there. So the point is you have instant trend analysis. You can see in this matrix here, that's a problem. You click on it, you have high definition evidence, yeah? So it's very powerful for the clients. We've done the same thing in wind turbines. So again, we discover a matrix for the client. We then are able to categorize the defects, And here you see, yeah, the contrast isn't great, but what you see there is a wind turbine blade. You have a defect. We click on the defect and we can zoom right the way to the measured defect. So the critical thing here with wind turbines is, you know, we're, I don't know, 4 to 6 times faster than the standard rope axis approach, but also we have fantastic high definition images behind each inspection ratings, and we have measurements of those defects. So it's a game changer for this particular industry, as it is for utilities. And again, we can drill further into the defects behind this particular blade, or defects on this particular blade. This is the next level of detail. So you start with a summary and you can then drill into that. But again, it's all very, very traffic lights. It's summarized, it's simple to understand information. And the way I tend to describe it to the clients is, this is the tabloid version of an asset management solution. It's very visual, it's map-based, there are traffic lights, but there's always high-definition evidence behind every single inspection rating. So that's tremendously powerful, because we're selling to people who are not particularly, shall we say, IT literate, but they get this because it is so, shall we say, suited to their industry and so visual and so intuitive. Okay, so that's IHOF as a concept. And just another, yeah, funny about the contrast here. Another example of what's in here is thermal analysis. So this is that's an inspection of a distribution line in Portugal, and you can see we're able to use a radiometric camera to get thermal analysis of that particular, this particular component. And here we have a small issue with the actual temperature rating here. We can see that there's potentially a problem with the clamp, because there's a 5-degree swing on the temperature of one particular part of that. So again, very powerful information, and all available just through a very simple click on a traffic light. Okay, so there's a few examples there. In terms of Cyberhawk then, the overall sell, so we're global, yeah. Solutions are certainly innovative. We're the first guys to develop this end-to-end solution, you know, from the data capture all the way through to the cloud-based software. And in terms of the actual benefits, I mentioned a number of these. It's safer, you know, you're taking people out of dangerous or difficult situations, reduction or elimination of working height, enhanced management information, so your decisions are more efficient and more effective. You have one source of truth with cloud-based data, so your collaboration is better, it's more effective, and which of course lowers total costs. And as I mentioned before, you increase the uptime as well. Right, so that was a bit of a sales pitch, but hopefully grounds you in where I'm coming from. Yeah, so Cyberhawk, we are the world leaders. We've been doing this for quite a long time. We have a number of tier 1 clients, and the exciting thing for them isn't the drone. I'll be honest, the drone is great. It's a facilitator, it's an enabler. What's exciting is the software and the reports and the intuitive interface they get. So this is the way we describe the value web. And I'm not going to go through this, don't worry, but essentially what you see is that at the top in the green there, I guess I have one of these somewhere. So in the green here, let's try it again.
It's on the back.
It's on the back. Oh, thank you. That's a trigger, there we go, I should have got that. Very well prepared. In the green here we see equipment, so this is the hardware. And you know, essentially, this is not where we play. There's a lot of exciting developments there. But this is the enabler, the solution you put into the air. Data gathering is something done by ROV operators, yeah. That's where Cyberhawk would be. And there's a lot of guys out there who are, you know, great pilots, great equipment, and they're capturing images, and that's great. That's you know, it's very much a valid use of the technology. But what clients are really interested in is this application or the value add layer. We take this book of photographs here and we convert that into, again, powerful asset management information. And we have a couple of different models here. So oil and gas reporting is different to our model in utilities, wind and rail. And survey processing that Paul mentioned before, again, that's different. In survey, we don't outsource it, we have a survey department, but we buy off-the-shelf software. Yeah, so that's in the survey world. In inspection, it's all our own software because it doesn't exist. We have to build that from scratch. So there's a real difference there in terms of the marketplace. And our asset management software is both processing and also visualizing, as you saw, in the cloud, the information. And then, of course, the bottom layer here is the clients and how they interact with this inspection and survey information. Okay, so that's the value chain as we see it. And in terms of service evolution, I guess 10 minutes in I get to the actual point of the presentation. So this is my view of where we are right now. So in terms of this continuum, very cliched matrix here, we have low and high pilot skill, okay? That's low to no. And then we have industry safe operating practice compliance, which is a great big mouthful. It means how demanding is that industry for you to work in it safely, okay? So oil and gas, very demanding. You want a farm in Texas, not very demanding, it's your farm, right? So let's come down to how I see this. So this is where a lot of Paul's presentation was. And you know, you're not actually flying the drone, you're programming a flight plan, and then it's going and doing that. So that's autonomous in a way. I mean, it's not smart, but it's autonomous. And this is very much, not demanding in terms of the safe operating practice, and low or no pilot skill required. And so I see, precision agriculture, land survey, photography, video, security is in that particular box. Yeah. So there, to actually answer the question of this presentation, we have a degree of autonomy, and it works there. That makes sense. This is the present case. When you come to high levels of pilot skill required, we have utilities inspection. So inspecting a pylon in an economically viable way. So one entire pylon, 160 photographs takes 10 minutes, one battery. That's kind of a high pilot skill level. Same with wind turbines. So again, we're 4 to 6 times faster than rope access. It requires a very efficient crew. They have to be very highly trained to do that effectively. The autonomous or the waypoint approach is just too slow. It's not commercially viable, and it's not very safe. Then we get to the real sweet spot for offshore wind, oil and gas, and onshore oil and gas. And this is high pilot skill and very, very demanding safe working practice requirements. We've had what we call hazard identification meetings maybe 3 or 4 times with clients in oil and gas before they'll trust us enough to let us go offshore. So I think here, this is the least attractive candidate for automation, because in that particular area, if you have an autonomous drone, it has been tried. I won't name the client or the service provider, but it's been tried, waypoints around a flare in the middle of the sea. It didn't go well, but that's not a surprise to me. Yeah? So this is one of these situations where it's quite possible that, given that, for example, a company like mine is audited by Chevron, Phillips, or ExxonMobil to the same standards they audit full-size helicopter companies, these guys are probably not going to be too convinced by an autonomous drone too soon. It will come. But in the short term, they want to believe that pilots know what they're doing. And then we get to this kind of strange box here. So not very much pilot skill required, but very demanding in terms of the actual compliance systems. And automatic internal inspection in oil and gas. So inside the tank of an FPSO or boiler inspection, for example, in a power station, nuclear, you could get a situation there where, it makes sense to have an autonomous drone because the consequences are manageable, and you can prove there's a number of hours on that airframe with that particular autonomy for that to be safe. But that's my view of where we are right now. So for me, right now we have autonomy there. Everything will change. I mean, as we get more confidence in the technology, as we address the ethical challenges we have, and Will certainly touched on this a lot. We had actually the last time I met Simon, we had an IOT conference, and we talked about driverless cars, and we said, okay, so that's great. We understand the rules of driving a car. It's quite a known situation, not simple by any means, but we know what's happening. So what happens when you put some ethics into the driverless car software? Let's say you've got your family in the car, and the driverless car software says, I'm going to minimize loss of life. And you have a football team crossing the road, and there's 20 of them, and they're thick. I don't mean they're dumb, I mean there's a lot of them in the same place. And what does the car do? Well, it's going to kill your family, because that's 4 guys losing their life, for example, rather than 20. So it's a dumb example, but think about that in drones. Think about that in an environment where we don't have the same knowledge we do of the rules of the road. And you get into a situation where autonomy, genuine intelligence becomes a little bit concerning. So we'll see where that goes, but that's our current state of the art, if you like. So, last slide. So drones and software. For me, I'm in the industry, of course. It's the next dot-com boom. There's a lot of exciting things happening, and it's a great place to be just now. The market is actually growing explosively. And in terms of our message as a company, clients are excited by drones. They're excited about the safety, but what they actually want is the information that comes from drones, not the data. They don't want the book of photographs. They want the powerful management information. And so they want compelling asset management solutions. And what we're finding is that a company like us with 3 years of development and the IP and the know-how with the software that converts data into information, we're in a very interesting place. And in terms of new market entrants, we didn't talk very much about, I guess we touched on it a little bit. Right now you can go to a company, let's take Drone Deploy as an example, why not? You can get your drone photographs, stick them on the web, press a button, and those will be processed into aerial land survey information such as an orthophoto. So that exists right now, and it doesn't cost anything. So in the survey area, so the bottom left box, we're already seeing some really exciting autonomous solutions for the drone capture, but also in the back office, there's pretty autonomous, essentially, solutions that are happening. So you're just pressing a button in the back office and it's happening. Now, in inspection, we have a different thing. Inspection is different because the drone market doesn't really understand the clients as far as we can see so far. So market empathy is not really there, and so the credible solutions are not quite there yet. And I'm not going to spend the time disassembling my competitor solutions, but that will change. They will learn. And so it's an exciting time there. So again, pilot training, you saw the box there. Inspection flying requires intensive pilot training to be safe, and that's in the short term, but the automation will increase and that requirement will diminish. And essentially you will find the low and the high pilot skill thing converging in a number of industries. And in terms of our back office piece, because it's a whole end-to-end solution we're interested in, so we have software-assisted inspection engineering, and that is very labor-intensive. It's software-assisted, it's as efficient as it can be, but it's still labor-intensive, and there's a huge opportunity there to actually automate that. That's why I mentioned image analytics. That branch of computing is very exciting in the drone space, of course, either geospatially or in terms of inspection. And in terms of the, what we see happening next, and it's a multi-lane highway here. Each vertical, so rail, renewables, utilities, oil and gas, it will find the degree of automation changing and going at a different pace, depending on the appetite of the people that regulate those industries and on the technology as well. So for example, one can imagine image analytics of wind turbine blades working really quite effectively, but image analytics on you saw some examples of power line inspection of pylons. That's a little bit more difficult. There's much more noise in those images. So it's going to be different paces for each of the verticals, but it's definitely going to happen, and it's going to happen in the field and also in the office as well. So it is an exciting time to be in the drone business.